All right, welcome to page 6 of the notes, page 2 of 7.2, and we're going to start off with example 5, where we're going to do the inverse Laplace of 1 over s squared plus s minus 20. Now, I don't have anything in my little cheat box that looks like 1 over a polynomial with 3 terms, or a trinomial for s squared plus s minus 20. So I want to switch up the way that this looks like. And a way to do this is by partial fractions. And the reason why I want to do partial fractions is if I can break this up into terms where it's just, s plus or minus something, then I have, a form for that. Or if I have s squared plus some number, I have a form for that. And so what I'm going to do is I'm going to break up this fraction by using partial fractions. So I take the denominator and I factor it. I get s plus 5 times s minus 4. And then I separate it, and I have a and b as my numerators. And now to solve for this, what I need to do is I need to combine these two. So I'm going to multiply s minus 4 times a and multiply s plus 5 times b so that I have a common denominator. And then I can multiply, this side times that side to get rid of the denominators. And so what I know is that a times s minus 4 plus b times s plus 5 has to equal 1. All right, so now I want to use my zeros, if I have any, first to go ahead and solve, for my a, for my b. So now I have two zeros. I have, I know a 0 is going to be positive 4 from s minus 4, and I know a 0 is going to be negative 5 from s plus 5. And so I'm going to start off with, what if s is equal to 4? So if s is equal to 4, what's going to happen is I plug 4 in. If I plug 4 in, the a is going to go away because 4 minus 4 is 0. So that goes away, and I have 1 is equal to b times 4 plus 5, or 9. So I have 1 is equal to b times 4 plus 5, which is 9. To solve for b, you divide both sides by 9, you get b is equal to 1 over 9. Same thing as I plug in my other 0. I know that the other 0 is negative 5. If I plug in negative 5, the b part's going to go away because that's the 0 for s plus 5. And so I have negative 5 minus 4, which is negative 9. So I have 1 is equal to a times negative 5 minus 4, which is negative 9. Divide by negative 9 to solve for a, so a equals negative 1 over 9. And now I'm going to plug this in here. So a, if that was negative 1 over 9, it's going to be negative 1 over 9 times s plus 5, plus my b is 1 over 9 times 1 over s minus 4. I'm going to treat the negative 1 over 9 and 1/9 as my coefficient, so I'm just going to do the Laplace transform of 1 over s plus 5. This is the exponential, where it's usually s minus alpha, but in this case, since it's a positive 5, that means that alpha was negative, so alpha is negative 5. So it's negative 1/9 e to negative 5t plus 1 over 9, 4, so e to the 4t. All right, and I'm finished. I did the inverse Laplace of that. And again, having to use partial fractions, it's been a while. We did it a little bit earlier this year, but again, it's going to come back in this section, and it's going to come back pretty hard. I'm sorry. All right, so we're going to do the same thing again with example 6. I don't have a form for this, but I do know that I can break this up in terms of partial fractions. So I need to factor it. Thank goodness this one's already factored. But if I notice, I have s and s squared, so there's 3 zeros that should be here. So what I'm going to do is I'm going to have s plus 2, and then plus, and have that under a, and then the next one is going to be x squared plus 4 in the denominator, but on top is going to be bs plus c. And the reason why it has to be bs plus c is because it has to be linear, because this is quadratic. It has to be 1 degree less. And so I'm just going to break this bs plus c into two different fractions, so bs over x squared plus 4 and c over x squared plus 4. And now here are my partial fractions. I'm going to go ahead and multiply. I'm going to multiply s plus 2 times bs and c. So there's that part. And then a needs s squared plus 4 there. And I'd get a common denominator with that, and denominators being the same, so those cancel out. So all of this is just going to equal the numerator over there, which is s. Now, s squared plus 4, there are no zeros there. It's okay. We do have a 0 for negative 2. As for negative 2, because s plus 2, negative 2 is a 0 for that. So we're going to use s is equal to negative 2. Well, if s is equal to negative 2, our left-hand side is going to be negative 2. And for our right-hand side, both of these terms are going to go away. So I just have negative 2 squared plus 4. Well, negative 2 squared is 4 plus 4, which is 8. So I have 8a plus 0 plus 0. To solve for a, I divide both sides by 8, so negative 2 over 8 reduces to negative 1/4. So now I have an a. A is negative 1/4. And now, my function, I can plug in for a to be negative 1/4. And when I do that, I'm going to go ahead and multiply. So a is negative 1/4, so it's going to be negative 1/4 s squared. And then negative 1/4 times 4 is just negative 1. The next one, I'm going to distribute the bs into s plus 2, bs squared plus 2bs. And for c, I'm just going to distribute the c into s plus 2. So I have cs, or sc plus 2c. Now what I'm going to do here to solve for b and c is I'm going to combine everything that has an s squared, that has an s, and that's just a coefficient. Or not, sorry, not coefficient, but a constant. So negative 1/4 and b are both with squared, so I'm going to put those together. And I'm going to set that equal to 0, because on the left-hand side, there is no s squared. So this would be equal to 0, because it would be 0s squared. Now, based off of this, I can go ahead and solve for b. Just add 1/4 to both sides. That s squared is not going to matter, because we know that this has to be 0. So b is equal to positive 1/4. Now, I can combine the next parts, which is 2b, because that's with s, and 2 and sc, because that's also with s. So I can do 2b plus c is equal to s, and have the s there. So it's really just equal to 1, and I could solve for that. I could solve for either b or c. The middle one I'd really not do, because you're going to have both b and c. Here I would just do those terms with s squared and the terms that are going to be constants. The two constants are negative 1 and 2c, because they both don't have an s. So 2c